So, the first time it takes. So we will spend 2 weeks, meaning 4 lectures in chapter 5. And still have, okay. And we will talk about evaluating performance of algorithms, and I want to get the ball rolling with this, and then I'll be doing a lot of writing on the board. I want to hear from people who are interested or about sports analytics, and even if you are not interested to get into the area, send me an email if you think this is a good idea or not. I think it's a very good idea, not because I thought about it, but because I know that a lot of people want to get into communications and do sports analytics. I think it's a fantastic field, and as I mentioned in my email to you, on November 19th, you'll hear more about it, the Vice President of Analytics from the Boston Red Sox will come. That has been confirmed. We scheduled, it's 3 to 5 p.m. in 420 Hayden, November 19th. His name is Jonathan Hay, and he already sent me actually some of the slides that he will use. And I hope that we can start a program in sports analytics here at Northeastern. So we are right here, week number 5. And so far, you can see these boxes, right? And I'll talk about them. But at the top, right, this part here, I will show you some things with JUMP, this ROC. Were people able to download that real statistics resource pack? That is a little bit weird. It turns out actually you don't need to do anything with it, because I have a way to do the same thing in JUMP. But I still want, if you have a Mac, install VMware and Windows on it, because then you can use it as a Mac and also as Windows. And this is a valuable thing to know to do. Right? It's very important. So this is the document that I want to open up, and you see I have 1 asterisk, 2, 3, 4. These are the items that I want to go through. So chapter 5 is from the Smiley book, and I will talk about sections of the other book, what pages, or how to find the material to study from the JUMP book. This was, I had videotaped all the lectures, and I lost them all. Actually, the Blackpool people lost them all. I did this 2 years ago, and that's why I'm redoing it. So part 1 of week 1 of chapter 5 is we will cover these topics. Confusion matrix or classification matrix. We'll talk about accuracy measures, this cutoff, one variable table, sensitivity, specificity, and the receiver operating characteristic curve. This was used in World War II. So this concept, ROC, has its origin in World War II when they had receivers, people sitting on a desk, and if you watch any documentaries from World War II, there was on the table round, and they had a stick, like the stick to take selfies, and they're pushing things on the map. So when they would detect something on the screen, on the radar, it was a blip. Well, at that time, they did not have the sophisticated equipment that we have today. They did not know if that was a friendly aircraft or an enemy aircraft. Because if they classified it as friendly, that means they would allow it to come in over our airspace and bombard us, right? If it was an enemy airplane and it was misdiagnosed as a friendly, they would do that. And if it was a friendly and they misdiagnosed as an enemy, that means you would friendly fire, right? You would shoot down our own soldiers. And then froze. It should not freeze. We don't have. Okay. Okay. Hello. Control Alt Delete. It froze. Well, so this is what we'll do this week. I wanted to show you something else here. When we have an algorithm that will do something, right? So let's say we have an algorithm 1, that will do something. And then we have algorithm 2. We need to have a way to compare these two algorithms. Which one is better? Also, we can have algorithm 1 with parameters 1, 2, 3 set with certain values. Same parameters have different values. We need to compare which one is better. Okay? So, and the way to do that is via testing comparing certain errors. And so the keyword here is error, right? We will use, there's a lot of terminology that I'm going to give you. One example that I like to use the terrible disease cancer as an example, because it's used a lot there. And also, we like to see a cure for it. Let's say that 1 means a person has cancer, and 0 means no cancer. Okay? You can use 1, or we can use plus, or the word positive. Okay? So the 1, the plus, positive mean the same thing. What is a possible error? Before we get to that, I'm going to put two things here. This is actual and this is predicted. I try to write big so that we can capture this. So, actual means actual or reality. Okay? Predicted, this can be done, the prediction can be done by X-rays, for example, or some program. Let me be more specific. If I put down plus and plus, this means that the person actually has cancer, goes into the hospital, takes X-rays, and the X-rays say, you have cancer. This is the reality. The X-ray is a prediction. So whenever I use plus plus, plus minus, minus minus, minus plus, the first one will represent reality. The second is prediction. So what does this mean? So this means that a person has cancer, takes X-rays, and the X-rays say, you don't. This means a person doesn't have cancer, takes X-rays, and the X-rays say, you don't, right? This is the person doesn't have a cancer, takes X-rays, and the X-rays say, you do. So you have an error here and here, right? These are called misclassifications. Right? This thing is still frozen. Unbelievable. Okay. Well, I prepared today as if I would not need anything. So, what we have, actually, I wanted to use it. Oh boy. Preparing. Somehow it rebooted. It's rebooting itself now. No, I know, but I was already logged in. Okay. All right. That's okay. So we will use a very important instrument called the classification or confusion matrix. Now, this can be done in a couple of different ways. I only will require one. So what we will have is, to the left, we will have actuality, reality, right? So this would be plus, minus. Anywhere I put a plus, I could put 1 with the word positive. But I use plus and minus, right? It's simpler to write. And this is prediction. Plus or minus. Okay. And we have horizontal totals, and we also have vertical totals. Okay. So continuing with cancer, right? Because whenever you mention the word cancer, we'll know somebody, and it's a terrible disease, and hopefully people will find a cure for it. But whenever I use cancer, we all pay attention. Okay, now, so here I'm going to put plus and plus. This is from here, and this is from there. So this comes from here, and the second one is the predicted. Here I'm going to put plus and minus, right? This is reality, and this is the prediction. Here I'm going to put minus and plus, right? This is reality, this is prediction. So the first one is always what is real, right? And here you have negative, negative, right? Let's see. I'm not supposed to write here. Okay. Now this can be read. All of this is in the document that I opened. See what it did? It rebooted itself. I didn't do it, and now it shows the same thing that I had, and now I can. Oh. All right. That's okay. Okay, so this is called classification or confusion matrix. So you can replace the plus with a word. So this is positive, 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 negative, negative, positive, negative, negative. So what I have here, so this can be, you can say positive, positive. Okay? Or TP. This can be positive, negative, right? You can also say positive, negative. So we have this. In reality, negative means no cancer, and this is positive, right? And so forth. So this is a negative, positive, and of course negative, negative. Okay, you are truly negative, non-cancerous, and there's a prediction by the X-ray, so you have negative, negative. You follow me, right? Now, when we have this, right? The proper terminology here, this is called true positive. So this is called true positive. Why do we call that? So it's called true positive because the prediction is positive and it's true. The prediction is positive and it's true. And it's positive. This here is called false negative. So true positive or TP. This is called false negative or FN. Why is it called false negative? The prediction is negative, but it's false. The prediction is negative, but it's false because in reality you are positive. But it's false because the reality equals to positive. False negative. Okay? I'm writing everything down because this is very, very important. This here is called false positive. False positive. Why? Because the prediction is that somebody is cancerous, like here, but it's false. Because the reality is that you're negative. You don't have cancer. And this is called, this is called true negative, okay? Because the prediction is negative and it's true. The prediction is that you are negative, you don't have the disease, and that is a correct evaluation. I also have at least 2 videos which are excellent, not mine. They're excellent by people that know very well, and I will recommend their names. Okay, so this is false positive, and this is true negative. Now, when actual is here and predicted is there, this is where these guys are. In some outputs, actual is at the top and predicted is here. The important thing to know is you can always get this if you have plus plus, you have true positive regardless if actual is here or there, all right? Okay, now, we have an overall error. The overall error is also called overall classification error. And this is called, so the overall error, right? Whenever I say error, I will imply overall error. And this is equal to false, actually not right, okay. This is equal to false negative plus false positive over true positive plus false negative plus false positive plus true negative. So, in my notes, I have some numbers that I want to put here. So, let's see. If I don't write actual and predicted, that is what I imply. So of course, instead of this, you can have a 1. Instead of this, you can have a 0. You have a 1 or a 0 here. Okay? Now, let me put some numbers here. So in total, here you have, this plus that, 286. We'll explain everything. So this is 226. The total should be 3,000. So this plus that is what? 5 plus 9 is 14, 9, 11, 7, 2, 10, 8, yeah. So, and this is 14, 14, All right. So you have 3,000 people. What this says is that of those 3,000 people, how many have cancer? In reality. They all go to the hospital. Before going to the hospital, how many have cancer? 286, right? This is a plus, 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 plus. So this is this and that, right? So we will call this, by the way, instead of actual, you will see the word observed. Actual or observed, same thing. So this is observed positive. Okay? So observed positive will be true positive plus false negative. Here. We will call this observed negative. Okay? Observed negative would be false positive plus true negative. Right? So this is observed positive, observed negative. I'm going to call this, see both of these, what do they have in common? That the predicted values are positive, right? They use PP, but I'm going to write predicted positive because I have because this can also be read as PP, right? But I'm going to say predicted positive, right? So, predicted positive is true positive plus false positive. You see, the PP, this is the predicted values. And then, predicted negative, and this is overall total, right? Predicted negative is this too. Predicted negative is false negative plus true negative. So there will be a lot of terminology thrown at you, but it all makes sense. And this is overall total, right? So overall total overall total is true positive plus false negative plus false positive plus true negative. Or it's this plus that and this plus that, right? Okay, I don't skip anything. Now, the overall error rate, it's good to have your calculators ready. So false negative is what? 85 plus false positive is 25 and overall is over 3,000. And so the overall error is 3.67%. So this is 0.0367. Don't put an equal sign, you say or 3.67%. What does that mean? It means that 3.67% of people are misdiagnosed. In other words, in reality they have cancer and they're told that you don't, or they don't have cancer and they're told you do. Which one is worse? To have cancer and told that you're not, or not to have cancer and told that you have? They're both bad. But one of them is worse than the other on the average. Which one is worse?
To have cancer.
To have cancer and told that you don't because you don't get the therapy. They're both terrible. Right? Okay. I'm going to be erasing things. Okay? So, of course, it's on a tape, but you're welcome to take pictures with your cell phones as well, right? Does anybody want to take any pictures? Okay. Now, 3:55, remind me again, okay, for the quiz. There will be no quiz next week. And then, so today's October 3rd, October 10 next week, the 17th is the meeting, right? So no quiz before and maybe after, but we'll see. But at least there's no quiz before the meeting, right? Okay, so we'll say that the error, right, is 3.67%. Accuracy, whenever I say accuracy, that means overall accuracy. And this is equal to TP plus TN over the overall total, right? And overall total, of course, is everything. And so these two guys are the problem. These are correct diagnoses. So this is 85 plus 2689 over 3000, and this is equal to 96.33%. And of course, you can say that.
Should be 201 plus 2,600.
Thank you. So these two, yeah. Yeah, look here. These two, yeah. Okay. So what you can say is that the error plus the accuracy must equal to 1. So accuracy is 1 minus error, error is 1 minus accuracy. All right? Now, this here is the confusion matrix with only 2 outcomes, right? Positive, negative. You can have a confusion matrix with outcome 1, outcome 2, because you can have positive, negative, gray area, very gray area, right? Let's do this one first. I don't know if we'll have the time to do the other one, the multi-case scenario. And whenever you have one of two, this is a binary. So here, there is something called the classifier. So the classifier says positive or negative. Who is the classifier? In the X-ray situation, the X-ray is the classifier. The X-ray says positive or negative. The classifier can be a person, a program, a machine, something, right? Anybody who assigns the subjects, people, okay, to a particular class, all right? Okay. Just want. All right. Now. So you have this. Okay, erase it. People who become doctors have to know how to deal, because they say false positive all the time or false negative. They know what that means very, very well. Now we have once error, once or positive error, positives error. Once error is false negative over true positive plus false negative. So one's error here will be 85 divided by 286. What is the meaning of that? If you were to say this in words, what is this? And this is equal to, I don't, what is it equal to? but it's 85 with 286. And then we have zeros error. I'm sorry?
29.17%.
29.17%.
72.
72?
Yeah.
Okay. These are numbers, by the way, that are used by, from the president to senators to the highest, the WHO organization. So these are actually real time. Zero. So the one's error is from all the positive people, right? From people who are positive. How many of them were misdiagnosed? Out of 286 people that are known, right, to have cancer, 29.7, 30% were misdiagnosed. That's extremely high. Zero's error is from the people that are negative. Oops, how many were misdiagnosed? So that would be false positive over false positive plus true negative, and this is 25 over 2714, and this is a much lower number. 0.92%. Okay. So this means out of 2,714 people who are healthy, 25 were told that they have cancer. The one's error is out of 286 who were sick, 85 were told that they are healthy, right? So you have the error, the overall error, you have the one's error, you have the zero's error. We will cover some other statistics as we are proceeding. Okay? Let's see. Okay. All right. So let me go back to the computer. All right? And so we talked about okay. It does its own thing. I'm not. That. All right. I'm going to ask to go to a different classroom. I've had enough of this. I think it remembers the previous clicks. Let's see. Oh my God, a miracle. Now, so we did the accuracy. We did the error rate. There's something called the naive rule. How many people in this classroom are seniors? Raise your hands. 1, 2, 3, 4. How many 5, 6? Raise your hands. I want to see. 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay, how many are juniors? 1, 2, 3, 4. You're both senior and junior.
No, I didn't raise my hand.
What you didn't? Okay. 1, 2, 3. Are you raising now? Are you junior or senior?
Is junior fourth year or third year?
Just, you're a junior. Don't worry about it.
They're vendors.
Don't worry about it. Okay. So, we have 4. How many are sophomore? Okay. How many are freshmen? Do you have a freshman? Okay. Who is the majority? Senior. Okay. So, the naive rule is called naive because even though there's something else called naive rule which means something else, but naive rule means this. If the student walks into the class, right, and we know nothing about the student, we will assume that the student is a senior because that's the majority. If you have nothing else to go by and somebody comes in, you'll say you assign the person to the majority class. Okay? To the class that has the majority. That's the naive rule. Okay? And many times it's used as a benchmark. Right? Okay. Tapan, call from that phone number 4357 and tell them to come here. And you tell them that I'm the professor here and that I want them to come. Okay. So that's the naive rule. Okay? I really wanted to use let's say, and so the whole idea is so that I don't have to write these things. Let's say that you have the following information. This is the actual class, okay? And this is the probability of being a 1 or of being positive. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Zero, 1, 2, 3. All right. And 0 here. And again, this is probability of being a 1, probability of being cancerous, right? We have a 1 followed by 0, 0, followed by 1, and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you have these 24 people, I think, right? And here you have 0.996, 0.988, 0.984, 0.980, 0.948, 0.889, 0.848, 0.762, 0.707, 0.681, 0.656, 0.622, 0.506, 0.471, 0.337, 0.218, 0.199, 0.149, 0.048, 0.038, 0.025, 0.022, 0.016, 0.004. Okay, the question is, who comes up with these probabilities? Okay, at this point, we don't care, but a classifier. So if these are 24 people, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So you have 24 people. And let's say that these 24 people have been going to the same hospital. Based on the last 10 years of their history, some program has assigned them a probability of being cancerous. You understand this, right? And what we do next, we sorted them by highest to lowest probability. This is very important for what we will be doing. Now, so this is the reality. 24 people, that is what is actual. Then we decide, somebody decides, a doctor, of a cut-off point. Okay? So let's say that we take the cutoff point equal to 0.5. And if the probability of being cancerous is greater than or equal to the cutoff point, then the prediction then we will predict the subject of being in class 1. That means cancerous. Otherwise, okay, the prediction, otherwise, yeah, we predict or assign, this is, we assign, predict or assign the subject to class 0. To class 0, right? So class 1 means cancerous, right? Class 0 means not cancerous, right? But this is the prediction, right? So, so here I can add another column called prediction, prediction. And this person is cancerous, but I want to predict, so should I predict 1 or 0 for this person? 1. Now, the first thing that I should do is 0.5 is right here. Right? So right here. This is the cutoff point. Anyone above the cutoff point will be predicted to be cancerous. You follow me? Right? Anybody below, even if I had a 0.500, you can, depending on what you do, you can decide to go with 1 or a 0 if there was a 0.5 here. So all of these people are predicted to be not cancerous. Again, don't worry about how the probabilities are generated. The software will generate those for us. Okay, now, what I want to do, this is very important, right? What I want to do is to generate the classification matrix with this cutoff point. So I'm going to use 1 and 0 here, so you can get used to, okay, I could have used a plus or a minus here. And here is the prediction. Okay, so this is true positive, this is false negative, this is false positive, and this is true negative. What number should I put here? How many 1-1s do you have? 1, how many 1-1s, right? Plus, plus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see that? How many? Here I have 1s, 0s, right? So how many 1s, 0s do you have?
Wait, how many zeros?
No. How many 1s, 0s? 1 and 0 here, right? You only have this one. Where does that go? 1s, 0. So this here is the number of 1s and 0s.
Oh.
So you have 1. How many 0 1s? 0 is the actual. How many pairs of 0s and 1s do you have? 1, 2, 2. And how many 0 zeros do you have? 0 and 0. The actual is 0 and the predicted is 0. Okay, 12 plus 1 is 13. 2 plus 10 is 12. I should get 24 here. This plus that is 14. This is 11. I should not get 20. It's given 25. I'm counting something twice here. So, we should add up to it should be 11. Huh? That should be 11, right? 13, this is 12. Yeah, right? So the total horizontal, the horizontal totals in this should be that. Okay? So, with this cutoff point, we have this confusion matrix, all right? I want you to change the cutoff point to 0.80 and fill this up. So this is with the cutoff equal to 0.5. So I want you to redo this with a cutoff point of 0.80. You should be able to do this in under a minute and a half. Okay? So the cutoff point is 0.8, right? Locate that first. find the first number bigger than 0.8. It's this one. So this is where the cutoff point is. All right? What did they say, Tapan? You saw it, right? I'm not making this up. It actually rebooted itself. It froze itself. I know they did a lot of work, but we're having other issues now. I have been screaming at people to replace this computer. It needs to be replaced. I will actually request to get another room. So, the answer to that is online. Is it for 0.80? What I have here. So, what did people get? What is the true positive? 7. False negative? False negative is, this is how you think, right? False negative is when you have ones and zeros. All you need to do is count how many 1 zeros you have.
It's just 1.
Okay? 1. How many 0 ones do you have? Very easy to count. You gotta be fast. 0, 1. You have 1 here. 2.
No, don't we have to redo it?
Yeah, it's 2. It's 2.
And this should be,
14.
is it 14? 7 plus 1 is 8. This is 16. This is 9. This is 15. You get 24. All right? Something like that. So the idea here is this. If you want to do this, if you want to keep doing this for different cutoff points, all right? So here's the cutoff point. Right? We used a cutoff point of 0.5, and you can find the accuracy for it and then the error. Right? The error would be 1 minus accuracy. Okay. But let's say that you wanted to do this for these different cutoff points, all the way to 0.95 and 1. For each one of them, you can find the accuracy, for the corresponding confusion, and the error, right? Okay. Well, let's see. It's logged on right now, and all right. And let's see how long it will last. Because there's something in Excel. You can do this in Excel. We can do this in Jump. I want to show it to you in Excel so you can see what is really going on. And this is frozen. Oh. Actually, let me go. Can I click here? It doesn't allow me to. There's something in Excel called I sincerely apologize for this craziness. Somebody big will hear about this. I will call the Chief Information Officer's office right after this class, and I will leave a very nasty message. I have done that before. Okay? um, okay. The idea is this. You you create this confusion matrix, and then you click some buttons in Excel, and it will fill in the accuracy and the error automatically. So this is called, here you have a table called one variable table in Excel. I wanted to show that to you. Okay, and and obviously I can't. All right. And then from this, I wanted to draw something, to plot something. Okay. So, put your books away. We will start the quiz. And, okay, just put everything away.